welcome to today's lesson. We are going to look at functions, and this is the first lesson that we are having under the functions. So in here we are going to look at how to find the inverse of a function and also how to find the function of functions. So the first the question here reads, the functions f and g, these are two functions, are defined by f of x is equal to 2x plus 1 and g of x is equal to 5x minus 1. Find a g inverse of x. So they want you to find the inverse of this function. So when you are finding the inverse, what are you supposed to do? So this is our function here, which is g of x is equal to 5x minus 1. So what are you supposed to do? The first thing that you have to do is to let g of x be equal to y. So let g of x be equal to y. So where there is g of x, you replace it with the y. So here where there is g of x, you are going to replace it with the y, which is going to be 5x minus 1. Then after that, you are now going to make x to be the subject of the formula. So you let this negative 1 cross the equal sign comes here, which is going to be a positive. In other words, you find the additive inverse of negative 1, you add it to the both sides. So this is negative 1, the additive inverse of negative 1 is 1. So when you add 1 this side, you add this one the other side, you remain with a 0. But in most cases, we just let this constant number cross the equal sign here so that it becomes a positive. So we're going to have y plus 1 is equal to 5x. In this case, our main interest is remaining with the x as our subject of the formula. So you're going to divide both sides with a 5. So that when you divide 5 divided by 5, it's 1. 1 times x, you remain with what? X, which is equal to y plus 1 over 5. So have we finished? Not yet. The last part now, you now let x to be equal to g of x inverse. And where there is y this side, you are going to replace it with what? With x. Since our function here contains x and not a y. So where there is x, we are going to replace it with what? With the g of x inverse is equal to, where there is x, where there is y this side, we are going to replace it with what? With an x. So this means we're going to have x plus 1 over 5. So this is our inverse, our g of x inverse. So after finding the f of g inverse, we are now going to find the f of g of x. So this one contains two functions within a function. So what is the procedure here? We know that f of x is equal to 2x plus 1, and we know that g of x is equal to 5x minus 1. So when you are solving this question, f of g of x, where there is g of x, you're going to replace the function of g of x, which is 5x minus 1 is equal to. So before we had included 5x minus 1, there was x here as f of x. So what is that function of f of x? It is what? 2x plus 1. So in this case now, where there is x in this function, we are going to replace it with what is the bracket? So we're going to have what? 10x minus 2 then plus 1, of which the final answer are going to have what? 10x minus 1. When you subtract negative 2 plus 1. So this same procedure here, this is our f g of x. When you follow it to this side also, it is the same. So when there's g of x, you replace the g of x. So I'm going to have 2, g of x is 5x minus 1, close, then there's plus 1. When you expand, you're going to still have the same answers, 5x minus 2 plus 1, and your final answer will be 10x minus 1 as the final answer. So this is how you find the functions, two functions in one function. Okay, then the last question, they are asking us to find the fg of negative 3. So this simply means in your equation there where there is a x, you replace it with a negative 3. Okay, so fg of negative 3. We know that our fg of x is 10x minus 1. So this simply means where there's x, we are going to replace it with negative 3. So our fg of negative 3 is going to be 10, open brackets, negative 3 minus 1. So this we're going to have negative what? 30 minus 1, which is going to give us negative what? 31 as our final answer of fg of negative 3. So this is how to find functions. Watch out for the next video under the functions, where we are going to explain more on how to find the inverse, also the functions of functions, more especially when you have the functions which are fractions. So thank you so much for watching. Please stay tuned for the next video. Welcome to the Christian Academy. This we're going to look at this question, which question reads, given that the determinant of minus 4 is equal to matrix as well as multiplication. So we have this question, so we have the matrix A, matrix B is equal to 1, matrix N is 0, 1. So even here, we've given the find the value of A, just for which determinant of B is equal to, like I explained in the previous. So just see the basically that we are going to use for us to find the value of x transpose, even the determinant, we are going to use minus and simplifying it is n multiplied by. So how do we find the determinant? Which means we are going to say to be minus. So how do you find a transpose? How do we find the determinant? So a transpose of a matrix minus is found by replacing the rows, multiplying the columns at the minus a for the rows. Okay, so we have this one should be equal to minus m. So when you look at the major diagonals in your matrix, and these numbers that are found. From there now, these are what we are telling us to find this. Then the minor diagonals are these numbers that are found here. Okay, so what are we going to do for us to find the value? So this row here we're going to give it the determinant and we have this Welcome to another segment. This is the question that comes in paper 1, and we're going to look at the transpose of a matrix and as well as multiplication of matrices. So we have the matrix M, which is 1, 5, 2, 7, and the matrix N, which is 0, 1, 2, 0. Then they're asking us to find M transpose. B, find NM. So when you just see M with a cat on top there, just put that they are looking for the transpose of M. Then NM, that simply means matrix N multiplied by matrix M. Okay, let's start. So how do we find a transpose of a matrix? So a transpose of a matrix is found by replacing the rows by the columns, and columns are being replaced by the rows. So we have matrix M, which is 1, 5, 2, and 7. Then they're telling us to find the M transpose. So our M transpose, this is our row and this is our column. So this row is going to become our column this side. So with that means we are going to have 1 here, then this 5 will come down here. Then this column will become our row. So we have 1 here and these 2 will come here. Okay. We go into the other one. This is your column and this is your row. So this row will replace this column and this column will replace this row. So these 2 will go on top, which is already there. Then this 7 is going to come there. Even vice versa, you're still going to have the same. This 5 will come here and the 7 is going to be there. So this is the transpose. So the only thing that is here is that a row replaces a column and a column replaces a row. I'll give another example of matrix A, which has got 1, 2, 3. When finding A transpose, that means these, they are going to become our column. So you have 1, 2, and 3. Just like that, this one becomes our transpose. So any question that you find talking about transpose, this is how you go about the transpose. Okay, so let's also look at the multiplication part of matrices. So how do we multiply the matrices? So they are telling us to find any M. So M is equal to the one which is starting, it is N, which is a 0, 1, 2, 0. Then followed by M, which is a 1, 5, 2, 7. So here multiplication goes row by a column. So this row should multiply the column. This row should multiply a column. This row should multiply a column. Just like that. So NM is equal to, so I'm going to multiply 0 times 1, it is 0, plus 1 times 2, that is a 2. So we are done with the first one. We shall use the same first row with the second column, which are going to have 0 times 5, you are going to have 0, plus 1 times 7, you are going to have the 7. So we are done with the first one. We go to the second one here. So row again by the first column. So 2 times 1, that is a 2, plus 0 times 2, that is a 0. Then we multiply again second row with the second column there. So I'm going to have 2 times 5, that is going to give you 10. Then plus 0 times 7, that is going to be a 0. 0 times 7, that is a 0. So now NM is going to be this plus this, that is 2, 0 plus 7, that is 7, 2 plus 0, that is 2, 10 plus 0, that is 10. So this is the answer. So whenever you're multiplying, you consider row by column operation. So the row must multiply the column, and you're going to have your first number there. Then again, the first row multiplied by the second column, you're going to have this number which will be in the first row but found in the second column. Then we come here, second row, first column. So you're going to have the number that is going to be in the second row but still in the first column. Then again, second row, then second column. So it should be in the second column, also in the second row, and also in the second column. And this is how the numbers are going to line up. This is all about multiplication and finding a transpose of a matrix. So most of the questions, if you have other questions that are pertaining to this subtopic, please feel free to inbox me. We'll be able to help you how to solve those questions. But this is the only thing that is found under the multiplication of matrices and finding the transpose of a matrix.